chapter before we hit the demos. So let's take a look at that. All right, so exceptions. We talked about these. When your computer is doing things step by step, everything's fine, but then something happens causing it to deviate from that, and those are called exceptions. The one we've been using here is the breakpoint int3, but this will also happen if you have an error, like division by 0 or attempt to access invalid memory. Then you're trying to execute the instruction, and for some reason you cannot execute the current instruction, so that triggers an exception. And so when the exception first occurs, the program stops executing and it returns to the debugger, so the debugger has the first chance at control, because of course, when you're debugging a program, it is very likely that the exceptions are what you want to analyze. So when you're under an exception, it stops and goes to your control, say, this might be what you care about. You can decide whether you want to handle the exception or just pass it back to the program. If you pass it back to the program, then you can see if the developer of the program included an exception handler. A properly written program will include code to handle bad things that happen. And it might have that. So you turn it back to the program, and then if the application doesn't handle it, then you get a second chance. Say, there was a problem, and you decide not to intervene, pass it back to the program didn't handle it. Now, if the program has an unhandled exception, it's going to crash, and it's going to pass it to the operating system, and then Windows will pop up a box saying your program has stopped working. And so you get a second chance in the debugger saying, okay, they didn't write any code that handled it. Now maybe you want to address it in your debugging session. And that's what happens here. First chance exceptions can therefore usually be ignored in malware analysis. They're just part of the operation. And by the way, it is fairly common for malware to use exceptions to reroute code. We'll do it in the exploit development class. We do it. You can hack the exception handler and put extra code in the exception handler, and then trigger an exception, and then it runs to your code. It's one of the many ways to run the code you injected. So you can ignore it typically, but second chance exceptions you can't ignore it. The program is crashing. So if you do return that back to the program, it will just crash and pop up Windows error boxes, and that usually means that the malware is not able to run in this environment. It wants to be in a different version of Windows, or it doesn't want to run in a virtual machine or whatever. Obviously the malware is crashing if you have that kind of exception. So here's common exceptions. int3 we've talked about. This is implemented as a software breakpoint. By the way, if you single step, which is F7 in the debugger, all it does is keep replacing every instruction with CC. That's all single step is. It's a whole bunch of software breakpoints. You can also there's a trap flag in the register that will automatically generate an exception after every instruction. This is a single step mode that's built in the processor. And there's memory access violation exceptions. This is very common, where you try to read or write or execute some location, and you're not allowed to go to that location. It's either an address where there is in fact no memory, or it's just an address that is outside the memory range reserved for this program. Both of those will cause an exception. All right, or you try to do something you're not allowed to do, because there are permissions in memory now. There's memory, for example, that is marked not executable. If you try to execute code there, it will generate an exception, it won't do it.
These debuggers haven't changed apparently in 40 years. Because I used to run a debugger back then.
Oh, not in principle. No, nothing much has changed. Nope, and the one we're using here is probably 15 years old. It was written for like Windows XP, Windows 2000.
You might have thought that the multiprocessing or threading might have brought some changes in the debugging.
If you use WinDebug, you can see the threads, and you can try doing multi-thread debugging, but I haven't done any of that. We're only doing the simple stuff here.
I think the debugger is only work on one core, so it's not multiprocessing thing.
It's a good question. I do not know how they handle multi-cores. Maybe.
Multi-core, you have to look at different core and then look at the register inside those cores. So this debugger is kind of like, you know.
Yes, it's a good point. I've never thought about how to handle multi-core things in a debugger. Everything I've done seems to be handling only one core.
Isn't multi-core parallel processing light? I mean, they dedicate certain cores to video and da-da-da-da-da-da-da-da.
Well, some programs are actually written multi-threaded so they can use multiple cores, but many programs aren't.
No, the latest is they like mix, like different core, tuning for different applications.
Yeah, this is a very good point.
That's like a high performance CPU, the current ones.
Yeah, and clearly debugging that would be a more complicated job.
Then you have to go for individual core. You have to go to the individual core.
Yeah, that makes sense. He's talking about debugging a program written to run on multiple cores. And yeah, I think none of the debuggers we're talking about here could handle that. All right, so another thing you do is violate privilege rules. For example, you might try to execute a kernel routine from userland, which is forbidden. So that would be trying to execute an instruction, which is a valid instruction, but you are not allowed to execute that instruction from your permission level. Yeah, good for pointing that out to me, Corinne, when people are saying I should repeat the questions. All right, so here's some exceptions. There's online lists of them all. So here's divide by zero, here's a single-step debug instruction, and so on. Here's the breakpoint, non-maskable interrupt, that sort of thing. There's a whole bunch of these possible exceptions. All right, so you can modify the execution with the debugger. For example, you can change things. You can change the code itself. You can change the instruction pointer. You could put a breakpoint at a call and then change the instruction pointer to skip over that function and go to the next one. You can also override instructions with things like no operation. We'll do all these things in the projects to modify code. You can test a function. You can test just one function without running the code before it. You could start there, load the parameters on the stack, and run that function if you want to. Of course, the program won't continue to run properly from that point because you set up an unexpected condition, but you can test them that way if you want to. All right, so in practice, here's an example of a real virus. I've mentioned before, most viruses target their attack. For example, in Russia, Putin will totally protect you if you're a hacker in Russia. You can advertise commercial services as long as you only attack foreign people. If you attack people in Russia, you'll get prosecuted in Russia. And most of the high stuff is made by militaries, and they only attack certain nations. So this is very common. They check what language is set on your machine, and they only affect you based on that. So if this one, if you're in Chinese, it uninstalls itself and does no harm. If you're in English, it just puts up a pop-up. But if you're Japanese or Indonesian, it destroys the hard drive. So this is a real virus. Apparently, somebody in China wanted to wipe out some people in Japan, and they didn't really want to involve anybody else.
Just out of curiosity,
Yeah.
How did the DOJ get to identify individual Russian officer hackers and put them in a criminal filing? How did they do that?
That's a very good question, and I don't know how they do it. The question here is, how do they identify individual Chinese hackers and Russian hackers and send out warrants? I don't know.
Yeah, to get into
there are a bunch of them on the wanted list, and I guess it's a good question. I think, however, the first thing that comes to mind is they infect their machine with malware and turn on the camera. I think we've totally done that. That would help. I mean, we're totally infecting them and hacking them while they're hacking us. So, but they also, by the way, we probably turn insiders who betray them and stuff like that. It's espionage, But I don't have any internal knowledge. That's the kind of stuff, that I'm not cleared for. But that's the usual techniques. So here's the code that does that. You call this Microsoft API call that gives you a number that tells you what the language setting in the machine is. And by the way, what Wai Kang said is correct too, of course. This is clearly not the Chinese military, or they wouldn't have done this. This is stupid. This is some kind of punks. It's like a joke. That's unprofessional to irritate the English people. You should probably do nothing to the English people, do nothing to anybody except a real target. That's what we did in Stuxnet. Do nothing to anybody except the real target. That's what the pros do. This looks like an amateur product.
Yeah, you want to hide. You don't want to
Yeah.
expose.
Yeah, well, maybe if you're an amateur, maybe you do want to just irritate people and then you can brag about it, So anyway, here's the English version. So if 409 is the code for English, so then it would run this code, then 411 is Japanese, 421 is Indonesian, and 4 is Chinese. So that's what's going on here. You call the Microsoft routine, it returns this value, and then you check for various values. Yep, an amateur would be doing it just to brag about it. The pros would be, have a more well-defined military mission. Wiping out the whole hard drive.
The pros already have a job, so they want to
Yeah. By the way, the Japanese part makes no sense too. Why would you just wipe out random hard drives in Japan? That just seems kind of pointless too. That doesn't seem like a military mission. That just seems like making trouble for no good reason. Yeah. Yeah.
The code for like English and Japanese and Indonesian, is that same or could it be different for each code?
No, that's defined by Microsoft. This is the Microsoft system call. You can make this call to find out what language you're in, and then it returns a number, and these are the numbers for these languages. Yeah. It's just determined by Microsoft. All right, so that, like I say, all your code is really just calling Microsoft routines. That's all you're doing, is running Microsoft's internal routines that they provide for you to do things. So, all right. So let's try another Kahoot, which is down here. I see we have the transportation secretary in our class. A presidential candidate, too. You know, Obama learned, I think, JavaScript or Python or something. He said everyone should learn to code, so he learned some code.
Interesting.
Yeah, yeah, he said he had, coding is the modern equivalent of literacy. Everybody should learn it. So he went to a class and learned Python or something. Yep, yep. He was pushing his education initiative that every school should include this as through K through 12, learning some coding, which is probably reasonable. What's that? Yeah, the current transportation is Pete Buttigieg, yeah. And he was the presidential candidate, and he's one of the top 10 contenders for next time.
And he's got $1 trillion to spread around the United States. He'll make some big connections.
Yep, yep. He's really good on Fox News, man. He's the only Democrat that can defend himself well on Fox News.
Well, every time he opens his mouth, it sounds like something intelligent falls out of it.
Yeah, yeah. He can handle a hostile crowd really well.
Yeah.
It's funny, I think the Democrats make a mistake of not showing up in Fox News more often to defend themselves. Anyway. All right, let's give it a shot. All right, so which item handles exceptions during normal program execution? Okay, the first chance, second step stuff only matters when you're in a debugger. The structured exception handler is how you handle exceptions. When an exception happens, it goes to this block of code, which is a bunch of if. If it's this one, it deals with that code. If it's number 1, do this. If it's number 2, do that, and so on. And that's what a professional programmer will have included. And if they didn't, it'll go to the operating system. All right. All right, so what kind of exception does not stop code execution and can usually be ignored? That's the first chance. The first chance just stops executing the next instruction, but goes to the SEH. And that's really a transfer of location, but it's not necessarily a fault. Now it might be handled by the SEH. But it does give you a chance in the debugger to intervene at that point if you want to, but you normally do not want to. All right, so Ring 3 process tries to access hardware directly, so what will happen? It's a violation of privilege. Ring 3 is user land, Ring 0 is kernel land. By the way, there are rings 1 and 2 in the hardware, but they're never used by any modern operating system. It's just 3 and 0 is all we use. 0 is the kernel that can do anything, and Ring 3 can only do certain things. And that's a privilege violation if Ring 3 tries to do a Ring 0 activity. All right. And that person will have to tell me who they are if they want their points. And you're high. Not all 3 times. Very good. All right. So, let me stop this recording and then make a separate recording for demos.